Welcome to Unit 4, Day 4. This is the basic version of today's lesson. If you were looking for proficient or advanced, please stop here and go back to find the other versions. Today's topic is multiplying polynomials, and we'll start actually with two examples because multiplying polynomials is all based on your understanding of exponents. So the simplest polynomial multiplication problem I can give you is if we were to multiply two monomials. These are monomials because they each have one term. Notice that there's no addition or subtraction. Of course, there's a -2, but that's different. We are just multiplying even though you see parentheses, so it's important to remember that secret operation right here. And in order to multiply polynomials, you multiply each element of the term together, and you keep them all together at the end. So what that would look like is for these two, we would multiply the coefficients, 3 and -2, to get -6. And then we would multiply the variables, x to the 5th and x cubed. And when you multiply two variables, what you really do is you add their exponents. So that becomes 8 because it's 5 plus 3. Make sure that you don't multiply. If you think about it, we've got 5 x's over here and another 3 for a total of 8, all being multiplied together. Now that can't be simplified anymore, so that is your final answer just like that. The reason I want to do a second example right away is that you need to be really clear about the difference between this situation and this situation. In this situation, we're not multiplying two monomials anymore. We have one monomial raised to the power of 2. So I could think of this as really being 3x to the 5th times itself. And using the rule from above, the way to do that would be 3 times 3, which is 9. And x to the 5th times x to the 5th is x to the 10th because I'm adding exponents. This is your final answer, but it's an opportunity also to look at another way we could have done this problem. Instead of taking that exponent of 2 and writing two different monomials, you can also distribute this exponent as long as you're careful about it. When we distribute exponents, we're not just multiplying numbers together. We're distributing it and making it an exponent. So this would become 3 squared, and that's 9. And then when you distribute here, the two exponents multiply together because we're raising this to a power of 2, which is different than multiplying it times another variable. 5 times 2 is 10, and that's another way to get your final answer. In the practice problems below, you're welcome to use either method. Take a moment to make sure that you remember these two key details. And then in the blank spaces, please solve these two practice problems. When you're ready to see the answers, press play again. Here are the answers to the first two practice problems. That's number 1. And here's number 2. The second example of multiplying polynomials is still a pretty basic one, but instead of multiplying two monomials, we're now going to multiply a monomial times a trinomial, 3 pieces here. Basically, this is just like the GCF problems from yesterday. I just wanted to show you that it's considered multiplication. To multiply this, I'm really just going to distribute the outside term. Remember that I am still multiplying, and in order to multiply variables, you add their exponents. Here's what it would look like. -6 times 3 is -18. X squared times x cubed is x to the 5th. -6 times -2 is +12. X squared times x squared is x to the 4th. And -6 times 1 is -6, keeping x squared. There are no like terms, so that is your final answer for that one. Couple key details for this type of problem. Distribution means multiplication, and that's what we're doing right here. But when you multiply, what you're really doing is adding exponents. So make sure that you understand this distribution is different than what we did for our shortcut with the exponent here. This is just multiplying a whole term. When you've got these details written down, you have two practice problems for down below. When you're ready to see the answers, press play again. Here are the answers to the second two practice problems. That's number 3. And here's number 4. The last example is to connect the dots between these exponents and polynomial multiplications. So there's a major difference between example 3 and part B that we did at the beginning. But some people may be tempted to think of them as the same. So let me just point it out to you. This is a monomial with an exponent. This is a binomial. There are 2 pieces with an exponent. When you have a binomial, you cannot distribute that 2 in. You're not allowed to do that. So you have to go that long way where you understand that a squared symbol means that we're really multiplying something times itself. And in this case, what we're multiplying times itself is this binomial 4x cubed minus 1. And once you write it out this way, you probably already know what's coming next, because this is a FOIL problem. If you multiply a binomial times a binomial, it means that you're really going to multiply 4 different times. And we use FOIL as a way to remember those 4. 4x cubed times 4x cubed is 16x to the 6th. We're multiplying, so we add exponents. 4x cubed times negative 1 is negative 4x cubed. Negative 1 times 4x cubed is another negative 4x cubed. And negative 1 times negative 1 is positive 1. For some reason, I'm not really sure why, a lot of people end up with the wrong sign there. So be a little careful with that last term. It's kind of a common mistake. All you need to do now is just add these like terms in the middle. So you get 16x to the 6th minus 8x cubed plus 1. And remember, when I add like terms, I left the exponent alone, and that's different than multiplying where you add exponents. Key details for this type of problem: make sure that you remember to use FOIL and don't distribute. And the last 2 practice problems for you look like this. And here are your answers.